So here I am in the attractiveness data set. I still have my filter turned on here for my analysis. And you can see that I have the descriptive results from the previous video. I just wanted to leave this up so I can show you in the event that you wanted to delete an analysis, you can right click and then click remove, and it will take that analysis out. So I'm going to go ahead and do a independent samples t-test. This is appropriate for this data set because I have in a continuous interval ratio dependent variable, which is the attractiveness score. And then I have a categorical independent variable, and the groups are independent. So in this example, again, we have the score for attractiveness, and then we have this independent variable mask, and that's actually the condition that participants were randomly assigned to be in. So I'm going to go to t-tests under analyses. So t-tests, I'm going to choose aptly named independent samples t-test. Now, the key here is that you're going to need to make sure that your independent variable, that it has one of these symbols next to it. So you can see that it needs to have these little 3 round dots. That indicates that it's nominal, or this little these little step ups in blue, that's that it's ordinal. So you cannot do a t-test if your independent variable is not categorical. I'm going to move that variable to my grouping variable. And then I'm going to move attractiveness to my dependent variable. And you can see that it's already calculating over here, but I'm going to select a couple other steps. So first of all, I want to think about my hypothesis. So you should have a one-tailed test, a one-tailed hypothesis that you're going to run. And in this example, the student's hypothesis was that people wearing a mask would have a higher attractiveness score than people not wearing a mask. So that would be this hypothesis where group 1 has a smaller attractiveness score than group 2. So you should make sure that it matches your hypothesis. And you can always go back and change it. That's one of the great things about Jamovi, but it's good to put that there and make sure that that matches what you're thinking about. Next, I want you to calculate descriptives. And it's going to give you the mean, the group size, the median, the standard deviation, and the standard error for each of your groups, which you'll need to report the mean and standard deviation and the sample size in your APA results. You can also do effect size here. So our effect size is going to be Cohen's D because it is an independent samples t-test. You can also select the confidence interval. And we will be talking about that in class as well. That's for the effect size. And then the last thing that we're going to do, I'm going to have you do a homogeneity test. And so this is the Levine's test of homogeneity of variances. And the idea is that we're testing an assumption of an independent samples t-test that our groups, that the group variances are approximately equal. So if we randomly assigned people to be in different conditions, we should have approximately similar variance. And so for now, you're just going to go ahead and calculate that. And then we're going to also click on this Welch's over here. So you're going to end up having a bunch of these different boxes clicked. So you can see that under tests, we have students. And then under hypothesis, we have our one-tailed hypothesis. We're going to leave the missing values as is. Under additional statistics, you're calculating the effect size, confidence interval, and descriptives. And then we're going to check the homogeneity of variance. You can also do a normality test, but I'm not going to require that. So that's up to you. And anything that you missed the first time around, you can always bring this into lecture and edit it, and we will talk about it in more detail.